Welcome to our introductory video on trigonometry. Today we will be uncovering the basic fundamental knowledge required to understand future concepts. So let's start with trigonometry. What is trigonometry? Many people often complicate trigonometry and make it seem harder than it actually is. Trust me, trigonometry isn't as hard as many people make it out to be. It's actually quite simple. By definition, trigonometry is a study of triangles and its as well as its shapes, as well as angles, its sides, and other characteristics. Broadly, it's a study of triangles. Doesn't seem hard now, is it? Study of triangles. This is the main thing. And in trigonometry, many people have actually already learned some trigonometry without even knowing it, with prerequisite classes such as Algebra 2 or even Algebra 1. One of the most basic and fundamental concepts and theorems in trigonometry that one would have to know from the get-go is the Pythagorean Theorem, which many people have probably already learned if they are going to take trigonometry. So the Pythagorean Theorem states that the two legs or shorter sides of a triangle are equal to the square of the hypotenuse, or the longer side of the right triangle, when the legs are each squared and added together. And this can be represented algebraically with the equation. It can be represented algebraically with the equation a squared plus b squared equals c squared. Now it's very important to differentiate between each part of the equation, because we have three letters, A, B, and C. A and B would each be a leg, so this would be A, this would be B. Each is a leg, and C is the hypotenuse. So as we said before, each leg is equal to the hypotenuse squared. So this is raised to the second power, hypotenuse squared, when each leg is squared and then added with each other. So here we have it, that each of these is a leg. It's a leg. And this is the hypotenuse, the longest side. I'll just write HYP as an abbreviation. So this is a fundamental theorem. It's very important. It's a very simple theorem as well, that is very useful when one does not have a side length in a right triangle. So it's very simple to find the missing lengths when you have a right triangle. With this theorem, we can also derive a distance formula, which the Pythagorean theorem and the distance formula can be used interchangeably, and I'll tell you why in a second. So the distance formula is mainly used when one is working on a coordinate grid and he has coordinates, or he or she has coordinates. So this distance formula and this distance formula is used to find slant lengths. So if you have a line like y equals x, and you would like to know what is the length from starting point at origin 0, 0, and the point 3, 3. You would like to know the length of, oops, 1 second, should use a line. So here we have a coordinate grid, right? And this is, let's say this is our line y equals x, and you would like to find the distance between the origin 0, 0 and 3, 3. You would like to find distance between origin and 3, 3. So you'd like to find this distance right here. And just label this 3, 3, 3. So in this case, it would be easy to use the distance formula, which is r equals square root quantity x2 minus x1 squared plus quantity y2 minus y1 squared. Y1 squared. And this is all under 1 square root. The reason that these two formulas can be used interchangeably is because upon inspection of the distance formula, one will notice that x2 minus x1 and y2 minus y1 are both lengths. They're both lengths. Thus, they can be substituted with A or B. Then it would be R equals A squared plus B squared. This is starting to look like our Pythagorean theorem. We have A and B, and now the only thing is that we have a square root on the A and B terms. If we square both sides, we will get R squared equals A squared plus B squared. And we will notice that R squared and C squared are essentially the same. They're both the hypotenuse, because A squared plus B squared equals C squared and R squared, meaning C squared and R squared are one and the same. Oops. So this is equal to this. They're both the same. Both the same. And if we did want to find out the length of this, as was given in an example before, we can use both the Pythagorean theorem or the distance formula. Many people find it easier to use the distance formula because of the coordinates, so let's use the distance formula here. So we would given x2 minus x1, so x2 is 3, and we know the origin is 0, so minus 0 squared, and then the same 3 minus 0 squared for the y coordinates. 3 minus 0, 3 minus 0 squared, and for the y coordinates. So with this, we'll get square root of 9 plus 9, which is equal to square root of 18, and this is equal to square root of 9 times square root of 2, so it would be 3 root 2. this is the length between the origin and coordinate 3, 3. And as you might see, there's a special correlation between the two legs and the hypotenuse. If we were to see how much the length of this from 0 to 3, this is 3 units, and this is also 3 units from here to here. This is 3 units, and this is also 3 units. And now this is 3. This is 3 root 2 units. Oops, 3 root 2 units. 1, and if we were to take this ratio down, divide each from, as you can see, the ratio is 3 root 2 to 3 to 3. You can take this down to root 2, 1, and 1. This is a special type of triangle, and we will hopefully discuss this in the next video. Thanks for watching, and I hope you learned something.